Hello, folks. You should be getting the whiteboard slides right now. I'd like you to save them on your desktop because you can go through them with me as I'm going through them here. I kind of hope you've already tried the practice exam on your own and that this is just a little review for the ones that you did not do well on or did not get correct and need a little help with. So I'm going to go through the review here as you go through it on your own or at your desk. The whole numbers, I should probably say we are reviewing for exam 2. I'm going to go back to this for a second. We're in unit 2. This is our review for our exam that we will take for the end of unit 2. It happens to be falling right now during our benchmark week, so this is a good way to do the review and the recording. Let's just start to work. Whole numbers are part of their irrational numbers. True or false? Well, I want to say that we have real numbers, which are all the numbers on the number line. I like to write that word with this little number line. And then I like to say we separate into two groups. One group is rational. We call them the rats. And the other group is irrational. So whole numbers are part of irrational numbers. Well, whole numbers are 1, 2, 3, and 4, right? Irrational numbers are things like root 5, root 7, things that we can't take the square root of. Pi is an irrational number. So are the whole numbers part of irrational numbers? No. The rational numbers and irrational numbers break into two sets, and they are not part of each other. So whole numbers are not part of irrational numbers. Mark every set that 1/3 is a member of. Well, 1/3 is a fraction, and that makes it rational, right? Rational numbers can be written as fractions. Irrational numbers cannot be written as fractions. It is not an integer because integers are like positive and negative whole numbers. -1, -7, -85, 85, those are integers. Whole numbers, I think we know, 1, 2, 3, 4, 5, 6, 7, and 1/3 is not a whole number. Is it a real number? All the numbers on the number line are real numbers. 1/3 is on the number line. It's a real number. So I think it belongs to both these categories. Compare these two numbers, choosing greater than or less than. Well, let me tell you first how I would do it, just me. Well, 1/3, I happen to know, but I could also put into my calculator, is about 0.33333. So it's like a little over 33 cents. 0.25 is 25 cents. That tells me that 1/3 must be greater than 0.25. But if I didn't know that, I could get my calculator to tell me. And I've gone through the steps with you here, showing you what I pressed on my calculator. These are the buttons I pressed to get what I got. And if you recall, when I get a 1 back, I'm using this math test right there, and I put in the greater than sign. If I get a 1 back, that means I wrote a true statement. If I happen to get a 0 back on my calculator, remember, that means I wrote a false statement. So that's how you tell, is it true or false? Did I put in the right sign? I get a 0 back, it was false. I put in the correct sign, so I got a 1 back for true. Hope you're using your calculator on me. The square root of 5 is irrational. The square root of 5 is most certainly irrational. We've kind of talked about that, so I'm going to move on. Find the median after putting the following numbers in order from least to greatest. If you need help, and I highly recommend that you use your calculator for help if you have any question about putting them in order, and then when we need to find the median, we're looking for the middle number. So let's look at order first. I obviously need to put my negative guys, and I'm going to remember that a number that looks really big but is negative is actually fairly small. So I'm going to put that one as the smallest number. Then I'm going to put negative 23 cents next. And let's see, that takes care of those two. Now I'm looking for the smallest number, right? And I think $1.83 is going to come next. After that, I think $2.50, and after that, $4. So when I look at decimals, I like to think of money. It helps me. Now I need to find the middle one. And I think that's pretty straightforward. $1.83 is in the middle, so that is our median. Not bad, huh? Let's keep going. Write the solutions in lowest forms. Please use your calculator. I'm really not going to punch all these into my calculator. I am going to remind you that this is how we do it. Again, my keystrokes are right here. I'm telling you each button that I pressed on the calculator. I tell you how to get your answer that comes out as a decimal into a fraction. So if you'll follow along, Each and every one of these will come out exactly perfect if you use your calculator. So again, I'm not going to do them all. I'm going to tell you to use your calculator. Same thing here, guys. Multiplication and division, if you will put every fraction that you type into your calculator into parentheses, that's a good idea. You don't always have to do it, but when you need it, you need it. So I just that's the rule. I put fractions in parentheses so that it never messes up. These will pop right into your calculator. I've reminded you here how to get absolute value. So this is my little guide. Remember these absolute value bars? We have to simplify what's in here first. Then we pull it out and make it positive when we pull it out. But if you want to do a little check on your calculator, you can get these absolute value bars right there on your calculator by using, I'm trying to point out where I am. Sorry, it's the second catalog right there. That's where you get the absolute value. But if you'll just use my screen history and punch in what you see here and learn from that, I think that you can solve everything on this page with your calculator. I hope so. I hope you come get help with your calculator if you're having trouble with it, because it is your lifesaver. Now we get into problems with variables, and we have to be more careful. They don't solve so easily on our calculator. We're now simplifying, and we need to remember that we add like terms, but we do not add unlike terms. We also have to remember PEMDAS, where it says we have to do this multiplication and this multiplication before we can do the addition in between them. So I'm going to start by saying 6 times 3 is 18, and there's an x, so I have an x. 5 times 2 is 10, again an x, so I have an x. 18 and 10 are like terms, so we're going to add them together and get 28x. And again, remember, we didn't change my exponent. When we add 18x to 10x, we get 28x, not 28x squared. Exponents only change if we were going to multiply 18x times 10x. Then we would get 180x squared. Just kind of reminding you of how that rule changes, because we got to kind of get that in our head pretty good. Simplify using the distributive property. I hope you remember that we need to multiply through. I also hope you remember that you are not going to add together 3 and 4 because they are not like terms. That's why we need to just multiply. So negative 2 times 3a is negative 6a. Negative 2 times 4 is negative 8. And I can write that in different ways. I like one sign like this. You might also see it written as plus negative 8. So either way is fine, but in algebra we usually try to get it down to just one sign in the middle. And we know, hopefully, that this negative sign is going to kind of overrule. If I'm adding a negative, well, I'm really subtracting, right? If the negative guy is making me backwards. Okay. So simplifying on number 18, this one's a big biggie. We need to make sure that we think of this as 3x over 3 minus 12x over 3. In other words, when we do addition, and I kind of want to show it this way, if I add 1/2 plus 1/2, what do? Well, I add 1 plus 1 over 2. So kind of taking this and gone backwards here. I've taken this and spread it back out again, put the common denominator into 2 fractions. The reason we do that is we need to reduce here to get x, and we need to reduce here to get 4y. So I end up with x minus 4y. You can think of this in a different way, and I'm going to just show you with this one, but I won't show you again. You can think of it this way. This is kind of the opposite of the distributive property. There was a 3 out here, and it was x minus 4y. And then there was a 3 on bottom. And look how that 3 reduced, but it reduced from both of them at the same time, which is why we needed to kind of separate them. So I get the same answer both ways I do it, and I'm only going to do it the longer way from here on out, but you can see both ways. So we took out estimating, and if you're just kind of wondering, you don't have to deal with these estimation ones because we kind of took it out of the curriculum. We didn't read it. We didn't worry about it. You don't have to worry about it on the test, and you won't see it on the test. You just see it here. Okay, so we are now evaluating on number 19, meaning we are given numbers to put in for a variable. Very simple. Take out the letter and put in the variable, and take out the letter and put in the number, and know that when we have letters next to each other, it means we'll multiply. So I really have here, instead of 3 times a times b, I have 3 times negative 2 times 5. So I'm going to say negative 2 times 5 is negative 10 times 3 is negative 30. Again, use your calculator if you need to. Evaluate. Again, 3 times negative 2. Look how I'm just taking out the variable, putting in the number. Then I'm going to follow PEMDAS and multiply before I add. So I'm going to kind of point this out with my highlighter. See how I need to multiply here and multiply here? And I said before I add, but I should have said before I combine. So I end up with 3 times negative 2 is negative 6. Then I'm just repeating the negative sign I see right here. And 12, or I'm trying to read my own writing, 12 times 4, 48. And negative 48, negative 6 over 3. I don't want to lose that bottom part. Let's see, 48, 9, 51, 2, 3, 54, negative 54 over 3. And I'm going to go ahead and use my calculator just to make sure I don't divide wrong. And 54 divided by 3 is 18. Since it's negative here, then my answer is going to be negative 18. There we go. What is this number rounded to the nearest hundredth, to the nearest tenth, and to the nearest whole number? So hundredth, just to remind you, is like pennies, and there's 93 cents. So it's that 3 cents that is our hundredth. And if I need to round to the nearest hundredth, then I have to look 1 digit further, and I notice that it's a 5. If it's 5 or higher, then I round this guy up a little bit. So here I have $28.94 if I'm rounding to the nearest penny or the nearest hundredth. This is to the nearest penny. Think of it that way. If I round to the nearest tenth, then I'm rounding to the nearest dime, the way I think of it. That's this digit here. And see, I have $28.94. That 4, now that I have to look one past it, but this time it's a 4, so I won't round up. And I'll simply get $28.90. That would be rounded to the nearest tenth or whole number or dime. Now I need to get it to the whole number. And again, I look at my whole number. I look 1 digit past it. That's the 9. Since that 9 is 5 or higher, I'm going to round to the nearest whole number by rounding up to $29. Okay, just a little bit on rounding. Again, an estimation problem we are not going to deal with. Let's look at 24. Zoe knew her trip to Austin was 584 miles. If she drove 9.8 hours, what miles per hour did she average on her trip? You may use the formula D equals RT, and I hope you know that that is distance equals rate times time. Your rate is your speed. And let's look at our numbers and see if we can figure out what they want us to do here. Zoe knew her trip to Austin was 584 miles. 584 here seems like a distance to me, so I'm going to put it in for that B. Equals some rate, and I think I'm being asked what rate, what miles per hour did she average on her trip? So it's the miles per hour, the speed, or the rate that I'm being asked for. I'll leave that as an R. And it tells me it took her 9.8 hours to get there, 9.8. So I have an equation now. I'm actually going to change colors. I feel like I'm running into it. And here's the way it might look a little better to you. 9.8 times R, oops, that's my point, 0.8 times R equals 584. Do you see here that if we divide by 9.8 on both sides, oops, and divide by 9.8 on this side, we'll figure out what R is. We're thinking, what do we multiply 9.8 by to get 584? So let's see, 9.8 divided by 584, and guess what? I totally punched it in backwards, and I'm glad I did. Because again, when I make those mistakes, it helps you not make them. What I really need is 584 divided by 9.8, and I get 59.59. And they want it to the nearest whole number. So I look at the number past, and I see that it's 5 or higher, and I'm going to round that up to 60 miles per hour. So what did I do? I thought, what would I multiply 9.8 by to get 584? And that brought me to, oh, I need to know how many 9.8s are in 584. Okay, another one we get to skip. We like that, right? K-12 stock changed these amounts over the last month. It went down to 6.32, it went down 2.56, it went up 5.7, and it went down 3 in December. What's the average change over the time period? They want us to add these up and divide by how many there are because they're asking for an average. So I would add these up by going negative 6.32, putting all my negatives together, negative 2.56. And by the way, I would get a calculator to make sure, but I'm going to try and wing it here. 6 and 2 is 8. 5 and 3 is 8. 6, 7, 8, 9 to 11. And notice I added all those up because they're all negative. Then I have one positive number, plus 5.7. And this is where I'm going to get my calculator out and make sure I don't muck up. So I'm going to say I have negative 11.88, and to that I am adding 5.7. I get negative 6.18. That's how much it is all added up together, but they asked for an average, so they want me to divide this by 4, and I'm going to do that on my calculator and get the overall average was down 1.545, and they didn't tell me how to round it, so I'm just going to leave it that way. To divide this by 4, and I'm going to do that on my calculator and get the overall average was down 1.545, and they didn't tell me how to round it, so I'm just going to leave it that way. So what did I do? I added up all the numbers, divided by how many I had, and that gave me an average. Estimate the area of a square floor if each side is 7.8. I hope that you know that the area of a square floor is the length times the width. When it's square and the length and the width are the same, we often say the area is the side squared because that's the same as side times side, right? Well, they're telling us that this one is 8.7. So if I want to estimate the area, I need to say 8.7 times 8.7, which I will do on my handy dandy trusty nifty calculator. I could also use my squared button, by the way. I'm going to get 75.69. That is a rotten 7. But my average area is 75.69. And if these are feet, then it is feet squared. Now this next one kind of goes the other way. It's telling us that we know that the area is 590. So they're saying what times what, knowing that those two numbers have to be the same, gave me 590. How do I find that? I take the square root of 590. I see what number was closest. And again, I can do that on my calculator. I'm going to go second and then push my x squared button because that gives me my square root. Then I'll put in 590 and enter, and I get 24.289. This asks me to round to the nearest whole number, so I only have to look at one digit past that whole number to see it's 0.2, so I don't go up, I just leave it alone. The nearest whole number, I think, is 24. Not bad. If you know a side, square it. If you know the area, square root it. My grandfather was 85. If you doubled my age and subtracted 5, you would also have 85. What is my age? You may want to guess and check here, and you may guess and check here. I'm going to not guess and check. I'm going to show you how I would think about it. When my grandmother was 85, grandfather, sorry, if you doubled my age, so my grandfather was 85. I'm going to write G equals 85. And I'll be M. So I'm M. If you double my age and subtract 5, so if you double my age and then take 5 away from it, and I kind of mucked up right in the equal sign, so let me get rid of that. Go back to that. If you take my age, double my age and add 5 of it, you would also get 85. What is my age? And again, you may want to kind of guess and check, and that's fine. Here's what I'm going to think about. I'm going to think about, well, if you doubled my age and added 5, isn't that the same as doubling my age and subtracting 5 would be the same as adding 5 to this. So I'm going to think of that as a 90. And then I'm going to go, oh, then 2 times something is 90. That means I need 90 divided by 2. And that is 45. So I think my age is 45. You may have other ways of guessing and checking. We will do more of solving this type of equation in Unit 3. So I don't want to get too in-depth in it. You can guess and check, play around with that one. How about 30? Have you seen the Pythagorean theorem before? Because that's what they throw in on you here, and they just want you to use it as a formula. So it says you have a right triangle with sides a equals 8, b equals 10. So they're just telling us, hey, put an a in there, put b in there. Well, a is 8, so I say a squared, plus b is 10, so I say b squared. And they want us to find c. Okay, 8 squared is 64, 10 squared is 100. That means I need 164, and that is equal to c squared. So if I know c squared, how do I get c? I take the square root of 164, and again, I need my handy-dandy trusty calculator. Second x squared of 164, and I get 12.8. It says round my solution to the nearest 10, and I think I get 12.806. If I'm rounding to the nearest 10th, I only have to look one digit past it. And it's a 0, so 12.8 is rounded nicely for me, I think. Okay, let's look at some examples of our different properties. I know these can be a little confusing, but I hope to give you a few little tips that help out. So let's start with additive inverse. First of all, I'm only going to be looking at the ones that say add, not the ones that multiply. So look at how I have 2 here that multiply and 2 that add. Actually, let's color code it. These are the 2 that add. And, oops, did I do it wrong? I'm just so rotten. Okay, so the multiplying guys are going to be red. If I can make that red go away, yeah, it can. And the other guys are blue. So which ones are multiplying? Obviously. When I get my pen to work again, that loves me again. There we go. Multiplying are the red guys. This says multiplicative identity. Does identity make you think the same? I hope so, because it's saying this guy. Saying, hey, if I multiply 6 times 1, I'm going to get the identical thing, identity. And then inverse makes you think, I hope, 4 and 4 over 1. You flip them. So that's the one that's going to be inverse. Now let's look at the add ones, the ones that are in blue. Additive inverse and additive identity. So of the additive ones, I see, again, identical. 3 plus 0 gives me the identical thing. And inverse makes me think of a positive and a negative. Those are inverses. And I get 0 when I add them, so those go together. How about commutative is to move? Do we remember that? Associative is who we play with, who we associate with, and that's our grouping symbols or our parentheses moving around. Distributive has that pattern where you have something on the outside of parentheses. And I don't know, reflexive, so maybe we'll just get there. We didn't talk much about reflexive, but it'll be the one left over. So commutative, which ones move from one side to the other? In other words, the order changes. And I see here 6, 2, 5, 6, 2, 5. I see no order changing. How about here? 3 plus 5, and on this side I see a 5 and then a 3. So this is the one to me that looks like it's commuting. It's moving the numbers. The numbers move. Which ones look like the grouping symbols changed? Well, there's 2 of them here that have grouping symbols. And I noticed on this one I have the exact same thing over here, 6, 2, 5 and 6, 2, 5. Only difference is those grouping symbols. So that's my associative property. The other one that happens to have parentheses is my distributive. It's the one that's telling me I got to go through those parentheses. It has that classic pattern. So this guy is that one. Reflexive, look at this guy. 7 equals 7. It looks like a mirror, doesn't it? It's just reflective. This is equal to itself. So it's almost a freebie, right? What else do we know? We know lots more, and we're almost done. Stick with me. I know there's lots here. True or false? Is this mess equal to 0? Well, I'm going to separate it out for a second. Negative 27 plus x plus 27 minus x. Well, I see a positive 27 and a negative 27, and it's all addition, so those must go away. Then I see a positive x and a negative x. Those are gone too. I agree. I think this is true. That's equal to 0. How do I simplify on 34? I'm going to look at it one step at a time. I see multiplication here. 1/4 times 4, and that is just simply 1. Think of it. What's 1/4 of 4? 1. So that just went away kind of. It's 1 times 100 minus, plus minus 7 plus 7. So now where do I look? I'm going to look inside here and go, oh, positive 7 and negative 7, that went away. All that's really left here is 100. Let's look at 35. This time I have the parentheses with a fraction out front and only one thing. So this guy is the distributive property. It wants me to multiply through. So it's saying, okay, what is 1/8 times 8n plus 1/8 times 8? I just kind of made it out the wrong one. I hope we've been catching on that 1/8 times 8 is 1. So I have 1 in here. Again, 1/8 times 8 here is 1. So I have n plus 1, and I think this is a true statement. Do you remember that we need to separate this guy out? So we need to say 4f over negative 4 plus 24 over negative 4. And then we need to reduce each piece. Careful here. 4 and 4 go away, but this negative sign does not. It hangs out with it. Negative f. Again, 24 and 4 reduces to 6, but that negative sign needs to hang out. So negative f minus 6 is what we end up with. Simplify using your knowledge of properties. Again, we're thinking about the distributive property, I hope. So we're going to multiply through here and get 8 times d minus 8 times 6, and 6 times 8 is 48, plus, and look at this, negative b. So I really could just say minus 8b, but I've got two signs in there, so I'll leave it for now. And plus 48, lost my pen, sorry, plus 48. Okay, let's try to think about what are like terms. Well, I have a negative 48 here and a positive 48 here. Negative 48 and positive 48 go to 0. Then I see a negative 8b and a positive 8b. So, hey guys, I'm 0. Nothing is left there. Let's evaluate using our square root, using our absolute value sign. And let's write the right numbers, Ms. Strong. Sorry. 21 minus the absolute value of x, but x is negative 10. So I'm going to write negative 10 inside there. I'm trying to make my absolute value bars kind of exaggerated to make sure they come out. Sorry. Okay, so now what? Well, now I say that 21 minus, and what is the absolute value of 10? In other words, how do I deal with this? Absolute value means take it out of the bars and make it positive. So I end up with 21 minus 10. When negative 10 comes out, it becomes positive 10. And 21 minus 10 is 11. Let's try that again down here. Absolute value, 9 minus 3 plus 5. 9 minus 3 is 6 plus 5. What is the absolute value of 6? Some of you want to say negative 6, but don't. The absolute value of 6 is just 6 because absolute value means make it positive. So look, we got 11 again. 11 for both of them. Interesting. What else can we do? We are so close, guys. I know you can do this and do well on this test. We are almost done. Evaluate, and I promise if you can do well on this exam, on this review, then you're going to do well on the test. So anything that you see here that doesn't really mesh with you, come talk about. Come ask questions because you are going to see it on the test. Let's evaluate here. I need to plug in what they give me for y, so I have negative 0.1, and I need to square that, plus 2 times what x is, which is negative 0.2. Kind of crazy numbers, guys, but really you can plug this in your calculator and be fine. What is negative 0.1 times 0.1? I might need to just make sure I don't mess that up, which I did, by using my calculator. And I get 0.01. So I'm just trying to decide where to write. I think I'll come over here. 0.01 is what I got when I multiplied this times itself. Now I'm going to multiply 2 times negative 0.2, and I will get negative 0.4. So I go minus 0.4. Now I can just put those together, and if it helps, You can say negative 0.4 plus 0.01. You can put them in your calculator however you see them. And I get the lovely answer. Yeah, it is a weirdo. Negative 0.39. And you're going to see some weirdos. But pop these in your calculator, guys. They're not so hard. They'll take care of your signs for you and everything. Find the value of x for each of the next two problems using your knowledge of properties to help you. So what would I multiply by 1 to get 5.2? I hope that you all know. The only way to get 5.2 by multiplying by 1 is if you multiply it by 5.2. The only thing that can go in here for this x would be 5.2. How do I get 0 when I have 12.85? Well, I add a negative 12.85. That's all I want you to see. If that x has got to be negative 12.85, if I'm going to add a positive 12.85 and get 0. 43, during 1 week in the winter, the temperature dropped an average of 3 degrees per hour for 5 hours. So it dropped 3 degrees, how many times? 5 times. I think it dropped 15 degrees. If the temperature was negative 4 at the beginning of the 5 hours, so we started out with a temperature of negative 4 degrees, and then we dropped 15 more degrees, I think we're going to end up at negative 19 degrees at the end. Makes sense? I hope so. Find a number whose product with 6 is the same as its sum with 60. You may want to guess and check or use a table. Be sure to check your answer for reasonableness. So you're trying to find a number, some number, whose product with 6. So when you multiply it by 6, it's the same as equals its sum, so that same number's sum with 60. So you're trying to find some x that will go in there and make this totally true. An x such that when you multiply it by 60, it's the same as when you add 60 to it. And I'm going to leave that for you. I'm going to leave it to play around with. I might show you some choices, like let's just try 10. What if I thought it was 10? Is 6 times 10 the same as 10 plus 60? I get 70 on this side and 60 on this side, so 10's not going to work, right? Play around with some other numbers, put them in there. I'm going to let you play with it. A rod, 12.5 feet long, is to be cut into 3 pieces. How many feet long will each piece be? I'm going to take 12.5 and I'm going to cut it into 3 equal pieces. So I'm going to divide it by 3, and again, I'm going to leave that for you to do on your calculator. 46, while you shop, you find a pair of pants on sale for a third off the regular price. The regular price is $65.50. How much will be marked off the price? And I want to caution you here. Sometimes you're asked, how much is the price going to be later? And sometimes you're asked, how much was marked off, or what was the discount? Be careful that you're asking the right question, answering the question you've been asked. So this one says regular price $65.50. How much will be marked off if they're a third off? I just need to find what's a third of $65.50, guys, and that's dividing by 3. I'll just point out that also $65.50 times 1/3, that's the same as dividing by 3. So you can do either one of those on your calculator, and again, I'm going to leave that for you. Oh my goodness, we have been through the whole review. That means that I have done a problem with you just like every problem on your Unit 2 exam. So I hope that you will do the practice exam, the practice review. I hope you will come and ask questions at COGA, or if you're in office hours, if you have questions before you take this exam. Okay, good luck. See you soon.